Hi students, this is Alex here. In this video, we are going to find the half-range Fourier cosine series for the given function f of x. So first we are going to write the formula, that is f of x equal to a0 by 2 plus summation n is from 1 till infinity an cos nx. Now to find a0, we use 2 by pi integral 0 to pi f of x dx. But f of x is made up of two parts. First part is integral 0 to pi by 2 and f of x is cos x, and we have another interval. So again 2 by pi integral. Now the interval is pi by 2 till pi, f of x is 0. So anyway second part is totally 0. We are going to integrate the first part. Cos x integration is sin x, and we have a limit from 0 to pi by 2. When we apply the upper limit, we get sin pi by 2 minus sin 0. Sin pi by 2 is 1. So totally this is 2 by pi. So we got a0, which is 2 by pi. Now we are going to find an. An by formula, it is 2 by pi integral 0 to pi f of x into cos nx dx, and this is 2 by pi integral 0 to pi by 2 f of x is cos x in this interval, and rest of the terms we are writing it as it is. And we have a second interval, so 2 by pi integral pi by 2 till pi f of x is 0 here. So the second part is entirely 0. Now we have only the first part. So 2 by pi, we always keep the n term as the first term. So we are going to rearrange this, writing cos nx first, then into cos x dx. We are going to apply the basic trigonometric formula. Whenever we have cos x into cos y, this is half cos x plus y plus cos x minus y. So we are going to add this and subtract this angle. Now 2 by pi integral 0 to pi by 2 1 by 2 cos of adding angle we get nx plus x plus subtraction of the angle we get nx minus x, then dx. So we can cancel these two. Then we left with 1 by pi integral 0 to pi by 2. Taking x common, we get n plus 1x plus cos n minus 1x dx. Integration of this will be sin n plus 1x by n plus 1 plus sin n minus 1x by n minus 1, and we have a limit from 0 to pi by 2. Applying the upper limit, we are going to get sin n plus 1 pi by 2 by n plus 1, then sin n minus 1 pi by 2 by n minus 1, and applying lower limit, every term will become 0. Now let's expand this one. So we have 1 by pi. If I multiply pi by 2 inside, this will become sin n pi by 2 plus pi by 2 divided by n plus 1. In the same way, this is sin n pi by 2 minus pi by 2 whole divided by n minus 1. We are going to expand this using sin x plus y formula. So this will become, I write the formula here, when we have sin x plus y, this is sin x cos y plus cos x sin y. So sin n pi by 2 cos pi by 2 plus cos n pi by 2 into sin pi by 2. this whole division, we have n plus 1. Similarly, the second part is sin n pi by 2 cos pi by 2 minus cos n pi by 2 into sin pi by 2. Whole division, we have n plus 1, sorry, n minus 1 in the denominator. Now, cos pi by 2 is 0. So, this part is 0, even this part is 0. And sin pi by 2 is 1. So, an we have 1 by pi cos n pi by 2 alone by n plus 1 plus, actually there is a minus sign. So, minus cos n pi by 2 by n minus 1. We can take cos n pi by 2 common outside, and this will be 1 by n plus 1 minus 1 by n minus 1. By taking LCM, we are going to get outside terms, we are writing it as it is. The LCM is n plus 1 into n minus 1. So n minus 1 minus n minus 1. After cancelling this, we have minus 2. So it is minus 2 cos n pi by 2 by pi into n square minus 1. This is our an. But this an does not exist when n is 1, because there is a term n square minus 1. So if n is 1 here, then what happens? Denominator will become 0. So we have to find a1 separately. So a1 equal to 2 by pi integral 0 to pi f of x into cos nx, but n is 1, so cos x dx. So as we know, this function is made up of two parts. So first part is from 0 to pi by 2 alone. F of x is cos x, and one more cos x we have. And second part is 2 by pi integral pi by 2 till pi, and f of x is 0 here. So 0 into cos x dx. Anyway, the second part is completely 0. This is cos square x 0 to pi by 2 into cos square x dx, and second part is 0. When we want to integrate cos square x, we have to replace cos square x by the trigonometric formula, which is 1 plus cos 2x by 2. We can cancel this, then we can integrate this. This is x plus sin 2x by 2, and we have from 0 to pi by 2. So this will become pi by 2, and when I substitute sin 2x in this place pi by 2, I get sin pi, which is 0, and lower limit is completely 0. So we left with only pi by 2, and outside we had 1 by pi. So 1 by pi into pi by 2, after cancelling this, we left with only 1 by 2. So substituting everything in our expansion formula, f of x equal to a0 by 2. So a0 is 2 by pi. So 2 by pi by 2. So I take denominator 2, and I have to write a1 cos x. But a1 is 1 by 2 into cos x. Then our summation starts from 2 onwards till infinity. And an, what is an here? Minus 2 into cos n pi by 2, minus 2 into cos n pi by 2 by pi into n square minus 1. So pi into n square minus 1 into cos nx. Now we have to take the constants outside. We can cancel this. So finally f of x is 1 by pi plus cos x by 2, and we can take the constants outside. Minus 2 by pi summation n is from 2 till infinity. We have cos n pi by 2 by n square minus 1 into cos nx. This is the required half-range cosine Fourier series for the given function f of x.